A warm welcome to all of you. Now we will see features of unsupervised machine learning theory with real-time examples. The first one, no labeled data required, works with unlabeled datasets, discovering patterns without predefined categories or target variables. Example, customer segmentation, grouping customers into distinct segments based on demographic and behavior without predefining categories. The second one, exploratory data analysis, analyzing new datasets to understanding structure and relationships before formal hypothesis testing them. So, in unsupervised machine learning, there are no labels or predefined outputs. The system is given raw data and asked to discover patterns on its own. Unlike supervised machine learning, there is no correct answer provided. This approach is useful when we don't know what we are looking for in advance. The example, in customer segmentation, customers are grouped based on behavior and demographics without defining categories beforehand. In exploratory data analysis, new data sets are analyzed to understand structure before forming hypothesis. Now go to the next one, clustering capabilities. Automatically groups similar data points based on inherent characteristics without human interventions. The example, customer grouping by behavior. K-means clustering to identify high value, occasional, and dormant customers based on purchase frequency. The second one, image segmentation, dividing medical images into regions representing different tissues or organs for diagnostic purposes. So, clustering is one of the most important abilities of unsupervised machine learning. The algorithm automatically groups similar data points together by measuring similarity. No human guidance is required during grouping. Examples, K-means clustering groups customers into high-valued, occasional, and dormant customers based on the purchase frequency. In medical image segmentation, images are divided into regions representing different tissues or organs are the examples of this unsupervised machine learning. The next one, dimensionality reduction, compresses high dimensional data into fewer dimensions while preserving important information. The example, principal component analysis for data compression, reducing 1000 product features to 10 principal components for faster processing. So, this speaks about real world dataset often have a large number of features. Dimensionality reduction reduces complexity while keeping essential information. This improves efficiency and visualization. The example has given PCA, which is principal component analysis, reduces 1000 product features to 10 principal components for faster processing. So, dimensionality reduction, which compresses high dimensional data into low dimensional data. The next one is anomaly detection or outlier detection, identifies unusual patterns or outliers that do not conform to expected behavior. The example, fraud detection, identifying suspicious credit card transactions that deviate from normal spending patterns. Network intrusion detection, spotting unusual network traffic that may indicate cyber attacks or security breaches. So, here it identifies unusual patterns or outliers in the data. Unsupervised machine learning is effective in identifying anomalies because it learns what is normal and flags deviations automatically. The best example, fraud detection systems identify unusual credit card transactions. Network intrusion detection spots abnormal traffic indicating cyber attacks in real time. So the next one is pattern discovery. It uncovers hidden correlations and relationships within data automatically. Example, market basket analysis, discovering that customers who buy diapers often buy beers, uh, a classical retail insight. It is from USA. And second one, gene expression patterns, finding groups of genes that activate together in specific diseases or conditions. This feature helps in discovering relationships that are not obvious. These hidden patterns provide valuable business and scientific insights. The example it has been given, market basket analysis reveals products frequently bought together, and gene expression analysis identify genes that activate together in diseases. So the next one, scalability, handles large volumes of data efficiently without requiring manual labeling efforts. Example, processing millions of user logs, analyzing website clickstream data from millions of users to identify usage pattern, analyzing large image datasets, clustering millions of photos from social media without manual tagging. So unsupervised learning scales well with the large datasets because no labeling is required. It is suitable for big data environment. Example, website clickstream analysis using millions of user logs, clustering millions of social media images without tagging are the best suitable examples. Data compression reduces data size by identifying and keeping only essential features. Example, image compression, using autoencoders to compress images to 10% of original size while maintaining a visual quality. Audio file compression, reducing audio file sizes by learning compact representations of sound patterns. Data compression reduces storage and computational costs by learning compact representations of data. The example, autoencoders compresses images while representing or preserving quality. By maintaining similar quality, it will try to compress the images. That is the advantage of this. Audio compression reduces file size using learned sound patterns. The next one is feature learning. Automatically discovers relevant features from raw data without manual feature engineering. Example, deep autoencoders learning image features, discovering edges, textures, and shapes from raw pixel data automatically. Word embedding, learning semantic relationship between words from text help. Here, instead of manually engineering features, unsupervised learning extract features directly from raw data, which is especially useful in deep learning algorithms, where it will try to extract from image and its related edges, textures, and shapes from raw pixel data automatically. And the examples, autoencoders learn edges and textures from images. Word embeddings capture semantic relationships between the words. The next one, association rule mining, discovers interesting relationships and associations between variables in large databases. Example, product recommendation systems, finding that users who watch action movies also tend to watch thriller movies. right? Association rule this is finding that users who watch action movies also tend to watch thriller movies. Cross selling strategies identifying that mortgage customers are likely candidates for home insurance products. Here, this technique identifies associations among items and is widely used in recommendation and marketing strategies. Example, recommending thriller movies to users who watch action movies also. Identifying mortgage customers likely to buy home insurance. So the next one is density estimation. Estimates the probability distribution of data to understand its underlying structure. Example, understanding customer distribution patterns, modeling where customers are geographically concentrated for store placements. So, examples, understanding customers' distribution patterns, modeling where customers are geographically concentrated for store placement, risk assessment, estimating the probability distribution of loan default rates across different demographic. Density estimation helps understand how data is distributed and supports probabilistic decision making. Identifying customers concentrates for store placements, estimating loan default risk across demographics. So, next one, data visualization. Transform complex data into visual representations for better understanding. The best example, clustering visualization, creating two-dimensional scatter plots and three-dimensional scatter plots showing distinct customer segments with different colors. Multidimensional scaling plots, visualizing similarity between hundreds of products in a two-dimensional map. We go with this, visualization helps humans understand complex patterns discovered by unsupervised learning. Example, two-dimensional scatter plots showing customer clusters. A multi-dimensional going to visualize product similarity are the best examples for this. Noise reduction filters out irrelevant information and focuses on meaningful patterns in data. Example, signal processing, removing background noise from audio recordings to enhance speech clarity, cleaning sensor data, filtering out erratic readings from IoT sensors to get accurate temperature measurements. And the next one is self organization, which creates organized structure from unstructured data without external guidance. Examples, self organizing maps, creating topological maps of customer preferences that preserve neighborhood relationships. And the neural gas networks, organizing product catalogs where similar items are positioned close together. Now, this explains about the 13th one, self-organization. The model organizes data naturally without external control, mimicking self-organization seen in nature. The example, self-organizing maps for customer preferences, neural gas networks for organizing product catalogs. So the next one, when we go with this, hierarchical structure discovery reveals nested relationships and hierarchies within data automatically. Example, taxonomic classification, organizing species into genes, family, and order based on genetic similarities. The next one, organizational structure discovery, identifying informal team structures and communication hierarchies from my email patterns. So, this feature identifies multi level relationships within data useful in classification and organizational analysis. Example, taxonomic classification of species, discovering informal organizational hierarchies from emails are the suitable examples for this. The next one, missing data handling. So, missing data handling can work efficiently even with incomplete data sets by identifying patterns, imputing missing values, filling in missing customer age data based on similar customers' demographic patterns. The next one, collaborative filtering, recommending movies even when users haven't rated most films in the databases. So when you go to this, unsupervised learning can infer missing values by identifying similarities in the data. Filling missing customer demographic values is an essential characteristic of this unsupervised machine learning. Recommending movies despite sparse rating where we are given. The next one, flexible adaptation, adapts to new data patterns without needing retraining on labeled examples. Adapts to new data patterns without needing retraining on labeled example. Example, online clustering. Continuously updating customer segments as new shopping behavior emerge during holiday seasons. Adaptive recommendation systems, adjusting suggestions in real time as user preferences evolve over their sessions. So, this allows systems to remain relevant as data patterns evolve over time. Online clustering during seasonal shopping, real time adaptive recommendations are the crucial and main examples for this unsupervised machine learning. Cost effective, eliminates expensive and time consuming manual data labeling processes. Social media content analysis. Example, social media content analysis, clustering millions of posts into topics without hiring annotators to label each post. Large scale text mining, analyzing years of customer reviews without manually categorizing each review. So when you see this, by reviewing labeling costs, unsupervised learning becomes economical for large scale analysis. Clustering social media posts without annotators, mining customer reviews without categorization are the suitable examples for this unsupervised machine learning. The next one is probabilistic modeling. Models uncertainty and probability distributions in data for better decision making. Example, Gaussian mixture models, modeling customers' lifetime value as a mixture of high, medium, and low value distributions. Topic modeling with LDA, discovering that news articles contain mixtures of topics like 60% politics, 30% economy, 10% health. So, models, uncertainty, and probability distribution. This feature supports uncertainty aware decision making. Uncertainty aware decision making is what facilitate for uncertainty aware decision making. Gaussian mixture models for customer value, topic modeling using LDA are the suitable examples for this probabilistic modeling. The next one is knowledge discovery, reveals previous unknown insights and information hidden in data. The customer preference discovery, finding unexpected product combinations that appeal to niche customer segments. The next one, medical pattern identification, discovering new disease subtypes based on patient symptom clusters. When we see this, the primary objective of unsupervised learning is discovering new knowledge, unexpected customer preference patterns, new disease subtype discovery. So the next one, last one, generative capabilities, learns to generate new data samples similar to the training data. Right? Generative adversarial networks, creating realistic images, generating photorealistic human faces that do not exist, are creating synthetic medical images for training. Variational autoencoders, creating new molecular structures for drug discovery by learning from existing compound databases. Some unsupervised models can generative in nature realistic data samples. GANs generating realistic human faces. Generative adversarial networks generate realistic human faces. Thank you.